Welcome to the Math Record. Today we'll be covering the ICTM Regional 2017 Division A Algebra 2. Okay, number 1. Determine the sum of the zeros for the function f of x is equal to x cubed minus x squared minus 6x. So, the question, since the question says determine the sum of the zeros, the sum of the zeros is basically the coefficient of the second highest term. So the highest term is x to the power cubed. So the next highest term is x squared. The coefficient is -1. Okay, so whatever that coefficient is, multiply that coefficient by -1, and that will be the sum of your zeros. So -1 times -1, that's 1. So your answer for number 1 is 1. Okay, so that's only the sum for the zeros, for all zeros. If you're looking for only the rational, usually it might work, but sometimes might not. But usually when it says zeros, so if it says zeros or it says real zeros, right, then you could just basically just use this technique. Whatever the coefficient is, multiply by -1, that is your answer. Okay, so number 1, answer is 1. Okay. Number 2, f of x minus 1 is equal to 3x squared plus 5x plus 6. Determine the value of f of 2. So we know f of 2 exists in this function, so x has to equal 3, right? Because if you put f of 3, right, as x, then you have f of 2. So that's 3 times 3 squared plus 5 times 3 plus 6, right? So this simplifies to f of 2, which is what we need to look for. And that's 9, that's 27, plus 15, plus 6. So that is 21, plus this is 48. So our answer for number 2 is 48. And that's basically it. Number 3, 5x squared plus 3 divided by square root of x is equal to axk plus bx to the power w. When written with rational exponents, determine the sum of k plus w plus x plus k plus w plus a plus b. Okay, so we have 5x squared plus 3 divided by square root of x, which you can also rewrite as 5x squared divided by square root x plus 3 over square root of x. Okay, square root of x is basically the same thing as x to the power 1/2. So thinking about that, when you're dividing exponents, you're just subtracting. When you're dividing exponents, basically you're just subtracting the exponents basically. So x squared divided by square root of x is basically just that x on the bottom as the base and 2 minus a half. So 2 minus a half is just 3 over 2. Okay, so 5x to the power 3 over 2. Plus, now we think about this. So we have 3 on top. And if you have an exponent on the, if you have a coefficient thing on the bottom, that's all. This is just x to the power of 1/2, right, on the bottom. So what you have to do is that you just have to multiply this by a negative. So it would just be x to the power of -1/2, right? So so then to find the value of a is 5, k is 3 over 2, b is 3, and w is equal to -1/2, right? So you just add them all together. So that's 8. 5 plus 3 is 8. 3 over 2 minus 1/2, that is 1. So the answer is just 9. 8 plus 1 is 9, right? So that's number 3. Okay. Number 4. Let log of x over 8 over 27 is equal to 3. Determine the exact value of x. Okay, so this part just usually means it's just a long sentence writing integer as common fraction. Okay, so we have log of x, 8 over 27, is equal to 3. So 8 over 8 is the same thing as saying 2 to the power, 8 is the same thing as 2 to the power 3, and 27 is the same thing as 3 to the power 3. That's equal to 3, right? So that means log x is equal to 2/3, and this is inside the parentheses to power 3 is 3. Right? If you have the exponent inside, there's a log rule, which means you can put the exponent outside. So it will be 3 times the log x of 2/3 is equal to 3. So divide 3 by both sides, so log x of 2/3 is equal to 1. So that tells us that x raised to the power of 1 is equal to 2 over 3. So x is just 2 over 3, right? So that's your answer. So number 4 is just 2 over 3. Basically just that simple. Okay. Number 5. Three integers are such that when the smallest of the three is doubled, the middle of the three is increased by 3, and the largest is left unchanged. The arithmetic mean of the three new values is 2 more than the arithmetic mean of the original three integers. Determine the smallest of the original three integers. Okay, so let's say we have three integers. Let's call that a, b, and c, right? So a is the smallest, b is the second, is the middle number, and c is the largest number. So the smallest of the three is doubled. The middle of the number is increased by 3, so b plus 3. And the largest is left unchanged. And then they say the arithmetic mean of the three new values, so 2a plus b plus 3 plus c, right? The arithmetic mean, then you have to divide by 3 because that's the mean of the three new values is 2 more than the arithmetic mean of the original 3, okay? So it's 2 more than the original mean. So a plus b plus c, the mean of this is the original mean is a plus b plus c divided by 3. And then this number is 2 more than this. So to make it equal, we have to add 2 on this side. Okay? So let's kind of move this up so we get a little bit more room. So let's first multiply 3 by both sides. So when you multiply 3 here, and you multiply 3 on this side, right? This 3 cancels with this 3, so you're just left with 2a plus b plus 3 plus c is equal to, this 3 cancels with this 3, so this just makes a plus b plus c. And then this 3 multiplied to this 2 is plus 6, right? So what can cancel out? We can cancel a c right here. We cancel a b right here. And then 2a minus this a is a. And this 6 minus this 3 is 3. So we know a is equal to 3. So determine the value of the smallest of the three integers. Well, we said our smallest was a, right? So this was our smallest. So that means our answer is just 3. So our answer for 5 is just 3. So far, 5 questions, pretty simple. Just exponents and simplifying and basically just polynomials. Okay, number 6. The polynomial 2 x to the power 4 minus k x squared plus k has x minus 2 as a factor. Determine the exact value of k. Express your answer as integer or common fraction, right? So common or improper. So to do this type of question, there's pretty fast method. It's called the remainder theorem. So basically, it states that if you have a polynomial, f of x, whatever that polynomial is, and f of x has a factor of x minus a, right? X minus a, and a is a number, right? If this is a factor of this, then basically, if you plug in if you plug in a into x, then it should output as 0. That's basically the theorem. So using that idea, if we have 2, okay, let's kind of exit this thing out. Okay, so that basically means that we have a 2 here. So we plug in 2 for x. So 2 times 2 to the power of 4 minus k times 2 to the power 2 plus k is equal to 0. Okay, so that's 32. 2 to the power is 4, so that's minus 4k, and this is plus k. So that is minus 3k, so 32 minus 3k is equal to 0. So 32 is equal to 3k. So k would then just be 32 over, so k is equal to 32 over 3. And that's your answer. And that's basically all you have to do. You basically just need to know that one simple theorem, which is one of the most commonly used, the remainder theorem, the rational roots theorem, and I'm not sure if this is how you pronounce it, but Descartes theorem. So Descartes theorem, or is it, or it's Descartes' rule of signs? I can't remember what the name is, but basically whatever these are. Okay, so number 7. Determine the coordinates of all points that are x-intercepts of the graph x, y is equal to x squared plus 6x. List your answers in the form of ordered pairs. Right, so to find x coordinates, that means you just have to set y is equal to 0. So 0 is equal to x squared plus 6x. So 0 is equal to x. Distribute out the x, so x, 6 plus x, right? So x times x, x squared. 6 times x is 6x, right? So that means x could be equal to 0, or x could equal to negative 6, right? So then if we plug in 0 into this equation, it's just going to output 0. And you plug in negative 6 into this equation, it also outputs 0. Because that's called the x-intercepts. So these are our two answers, 0, 0, and negative 6, 0. And that's basically it. Just basic polynomial terms. Number 8. G of x is equal to x minus 1 in parentheses squared, where x is less than 1. So basically what they're saying is that we have a parabola, and it has a center at x minus 1, and it's going at 1, right? At 1, and it's concave up, right? But then it says x has to be less than 1. So if x is less than 1, the only domain is right here. So we cannot have that side of the graph. So it's just all this. Okay? So determine the exact value of g of negative 1 is 4. So basically, if he has a g to the power negative 1, it basically means inverse. So 4 is not our x value. 4 is our y value, basically. That's what it means to be inverse. So we have like a like our value right here is 4, right? So all we have to do in this type of question is that we just put 4 as our y is equal to x minus 1 squared, right? So taking the square root of 4, that is plus or minus 2, right? So is equal x minus 1. So our x could either be, if this is plus 2, then x could be equal to 3, or x could be equal to negative 1, right? But they said x has to be less than 1, right? So the only possible answer is negative 1. So the answer for number 8 is just negative 1. Okay. So number 9. Let the absolute value of x plus the absolute value of x minus 2 close absolute value is equal to 30. Determine the values for the solutions for x. Okay, so let's work inside out. So absolute value x. So if x minus 2 is a positive number, we could just leave it as positive. So we just x minus 2, absolute value is equal to 3. Okay, and if x minus 2 is a negative number, we just need to multiply by negative. So x times x minus 2 times negative 1 is equal to negative 1 times x is negative x, and negative 1 times negative 2 is plus 2. Okay, and that is equal to 3. Right? So x minus x, that's already 0, so that cancels each other out. So 2 is equal to 3, which is not true. So this entire equation is out. Okay? So we know if we simplify this, we have 2x, absolute value of 2x minus 2 is equal to 3. Okay? So we know that is true. So now we could simplify this version. So if 2x minus 2 is positive, we would just leave it as 2x minus 2 is equal to 3. And if 2x minus 2 is negative, we could just multiply the inside by negative 2. So that's negative 2x plus 2 is equal to 3. So that means from just this equation, 3 plus 2 is 5. 5 divided by 2 is 5 over 2. Okay. And x for this equation, 3 minus 2 is 1. And 1 divided by negative 2 is negative 1 half. So we have these two answers, but we need to check if they're extraneous, right? So we have x, absolute value x plus absolute value of x minus 2, absolute value, closed, is equal to 3. So we plug in 5 over 2 here. 5 over 2 is the same thing as 2.5, right? So 2.5 here, 2 minus 2.5, 2.5 minus 2 is 0.5. And then x, which is 2.5 plus zero point 0.5 is 3. So absolute value of 3 is 3. So this thing makes sense. Okay, so we know this answer is correct. Now we have negative 1 half. Okay, So negative 1/2 minus a negative 2, that's negative 2.5, right? Absolute value, that's 2.5. And we know x is negative 1/2, that's negative a half. So 2.5 plus negative a half is 2. Absolute value of 2 is 2. 2 is not equal to 3, okay? So this is not an answer. So the only answer is 5 over 2 because negative 1/2 is extraneous, which means it's even though it kind of fits the arithmetic, it kind of fails the actual like equation, right? So the only answer for number 9 is 5 or 2. Number 10, 2 to the power of x to the power 2 is equal to 4 times to the power of x times 8 is equal to 64. Determine the value for x such that the equation is true. Okay, so we got, if I ever see exponents or multiplying each other, I put them in the same base. So it's 2 is the smallest, so 2 to x to the power 2 times 4 is 2 to the power 2, so 2 to the power 2 x times 8, which is 2 to the power 3, and then 64 is 2 to the power of 6. Okay, so when you're multiplying exponents with the same base, you basically just add them together. So it's x squared plus 2 times x is 2x. So x squared plus 2x, and then plus a 3. Okay, and that is equal to 6. So that means x squared plus 2x minus 3 is equal to 0. So we could simplify this as x. And we have, since we need it to be positive, that means this side is plus 3 and this side is minus 1, right? So x squared plus 3x minus x, so that's plus 2x, then minus 3. Okay, so x could equal to 1 or x could equal to negative 3. So you can plug this back into the equation, so that'll be 1. Actually, you could just plug it back into this equation, right? So 1, 2 to the power of 1 to the power 2, that's 1. And then, so that's 2 times 4, which is 8, times another 8 is 64. Okay, so 1 works. So 1 is an answer. Okay, so x is equal to negative 3. So 2 to negative 3 to the power 2, that's 9. So 2 to the power of 9 times 4 to the power of negative 3. So that's the same thing as um, having 2 to the power of 9 divided by, well, times 4 to the power of negative 3, which is the same thing as saying 2 to the power of negative 6, which is also the same thing as just 2 over 9 divided by 2 over 6. So that is equal to 2 over 3. That's 8. And 8 times this remaining 8 is equal to 64. Okay, so negative 3 also works. So our answers for number 10 is 1 and negative 3. So even though we have the math out, even though they're both correct, we always need to check if there's extraneous just in case. But usually for exponents, there usually isn't unless there's radicals or absolute values. Usually, as I see. As I see right now, number 11. Determine all values for x that satisfy 18x plus 9 square root x minus 2 is equal to 0. Express your answers as an integer or as a common or improper fraction, right? So we have 18x plus 9 square root x minus 2 is equal to 0. So one way you could do this is that you could isolate the square root x and the x. So you have 18x minus 2, and then you have the 9x squared moves to the other side. So minus 2 is equal to negative 9 square root x. Okay, and then you could square root both sides. So 18 squared is 324 x squared minus 36 minus 72x, and then negative 2 squared is plus 4. And then 9 times 9 is 81 times x, right? So 324x squared minus 153x plus 4 is equal to 0, right? And then I'm guessing the way to do this is to use, we have x squared, so I'm guessing it's 81, right? Because you need to make this an odd, and that's probably one of the only ways. Oh, sorry, I put x squared there. 81. And this would be a 4x. Okay, so how do we do this? We have a plus 4. So maybe a minus 4 here. 324. Let me check if this math is right. 324 minus 36 minus 72. And then 81x. Okay, plus 4. So then minus 153. Okay, so that is correct. Okay, so if this is an 81, then we have a 4 here. Then if we put a 4 here, that's 324, so that doesn't work. So what is another number we could use? Okay, so 324, maybe a 9. Okay, so 9x, x. And we have a, oops, sorry. So we have a 2, that is a 36, x, right? So we can have a minus 1 here, and then minus 4 here. So minus 1, that's negative 9. 4 times 36, that's 72, 144. Plus that 9 is 150. Okay, so we know that is true. So that means x is equal to 9 over 4, or x is equal to 1 over 36. So we gotta always check for extraneous. So if you put 9 over 4 into our equation right here, that is 3 over 2. So 9 times 3 over 2 is 27 over 2. And then 9 over 4 times 18. So 18 divided by 4 is equal to 9 over 2. And that will be equal, times that 9 is 81 over 2. Okay, so adding them together, that's 108 over 2, and that will be equal to 54. 54 minus 2 is not equal to 0, so this answer is not true. Now, if you have 1 over 36, you can plug it in. So 18 divided by 36 is 1/2, and 9, the square root of 36 is 1 over 6. 9 divided by 6 is 9 divided by 6 is equal to 3 over 2. 3 over 2 plus 1/2 is 4 over 2, which is equal to 2. 2 minus 2 is equal to 0. So this answer is true. So the only answer is 1 over 36. And that's one way to solve it. But you have such big numbers, as you see, I got confused a bit. So another way you could do this is that you could substitute square root x as another variable. Let's call it a, right? That means 18a squared plus 9a minus 2 is equal to 0, right? Because if square root x is equal to a, that means if you square both sides, right? Square both sides. That means x is equal to a squared. So we could substitute that from x here, right? So that would be 18x squared plus 9a minus 2. So to do that, we could just simplify. So I see a minus 2. So let's say this is if that's a 9, nope. So 6 and 3 maybe. So 6, yes. So 6a and 3a. So this one is a plus 2 and this one's a minus 1, right? So that's a plus plus 12 minus 3 and then plus 9 and then minus 2, right? So a is equal to 1/6 and a is equal to negative 2 over 3, right? But remember, a squared is equal to x. So if we want to find x, which is what we're looking for in this thing, we just need to square it both times. So 1/6 squared is 1/36, and a is equal to negative 2 squared, which is 4/9. And then you could do the same thing with check extraneous, and you'll find out that 1/36 is the answer. And this is another way you could do it, which is a lot smaller instead of using the previous method. But both ways, your answers come out as 1/36. So that's number 11. Number 12, the circle a squared plus y squared is equal to 25 is intersected by the line y is equal to x minus 1 at points A and B. Determine the exact length of A and B. Okay, so we already know we have x squared plus, we already know what it says plus y squared is equal to 25. We already know what y is. Y is equal to x minus 1. So we can substitute that in. So x minus 1 squared is equal to 25. So we have x squared. Expanding this out, that's x squared minus 2x plus 1 is equal to 25. So adding them together, that's 2x squared plus, 2x squared minus 2x. And then 1 minus 25 is minus 24. It's equal to 0. Divide 2 from each term. So 2x squared divided by 2 is x squared. 2x minus 2x divided by 2 is minus x. And negative 24 divided by 2 is negative 12 equals 0. And this could be put as x minus 4 and x plus 3. Plus 3, right? So that's x squared plus 3x minus 4x, so that's minus x, and then minus 12. Okay, so that's equal to 0. So x is equal to 4, or x is equal to negative 3. Okay, so we know what, so if x is equal to 4, then our y value, you can plug into our equation right here, right? So 4 minus 1 is 3. So this coordinate, this point is 4 comma 3. Okay, if our x-coordinate is negative 3, we can plug in this equation again. So negative 3 minus 1 is negative 4. So for this value, our y value is negative 4. Okay, so this is our points A and B. It kind of doesn't matter which one's A and which one's B. We just need to find the length of AB. So the distance between 2 points, which is the length, is basically you subtract the distance from each other and square it, and then square root it. So that add them and then square root it. So 4 minus negative 3. Okay, so let's just do this because I don't have room. So 4 minus negative 3 is 7. So that is 7. And then you square it, and then plus 3 minus negative 4 is 7. So that's another 7. And then you square that one. And then you take the square root of that entire thing. Okay, so 7 squared plus 7 squared, that's just 49 plus 49. And that is 98. And square root 98 is equal to 7 square root 2. Right? Because 98 is equal to 49 times 2. So if you're taking the square root of both sides, right, you square root the 49, which is 7, but you can't square root the 2 because it's not a perfect square. So your answer is 7 squared 2. Another way to do this instead of adding them is that if you already got to this step, if you have two numbers the same, usually you just write that number again, so it's a 7. And then you take a square root, and that square root is 2. So whatever that number is, you multiply that by square root 2, and that's your answer. Okay, so the answer for 12 is 7 square root 2. Number 13, the sum of all positive integral values of n such that 5 is less than n factorial is less than 2017. So as I recommend that you probably use a calculator for this one, but I'll show out of what you need to do. So it's not that it's hard or anything, it just saves time. So if n is equal to 1, 1 factorial is 1. If n is equal to 2, 2 factorial is 2. If n is equal to 3, 3 factorial is 6. If n equals to 4, 4 factorial is 24. If n equals to 5, 5 factorial is 120. If n is equal to 6, 6 factorial is 720. If n equals to 7, 7 factorial is 140. 49 is 5040. Okay. So so what numbers are between 5 and 2017? So 5, so which one's bigger than 5? It's when n is equal to 3. And then when is it less than 2017? So n is equal to 6, because at n is equal to 7, it's greater than it. So it happens from 3 to 6. So add all the possible numbers. So we have a 3, 4, 5, 6, all in between, right? So a 3 plus a 4 plus a 5 plus a 6. So that's 7, that's 12, and that's 18. So our answer for number 13 is 18. But if you have a calculator, what I recommend to do is just spam the all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc., etc. If the number is really big, but since it's small, you're probably only gonna go up to 7. And then find out which numbers you need that are between it, and then just add those together. So if on your calculator you find out that you need to go up to 7, and then you find out that you start the equation starts working at 3 until it ends at 6, and then you just add them all together, and that's 18. So using a calculator is like doing it by hand is good too. It doesn't matter, but you'll get the same answer regardless. It's just that if you use a calculator, you're gonna speed up your time. So you get a lot more time to do other questions, right? So number 14. Determine the product of all distinct numbers in the domain of the relation 5, 2, 5, comma 2, 4, comma 0, 6, comma 2, 854, comma 2, 6, comma 7, and 4, comma 2. So this product of all distinct numbers in the domain. So the domain means the x-coordinate. So basically, what numbers do we have in the x-coordinate? We have a 5, we have a 4, then we have a 6, then we have 854, then we have a 6, and we have a 4. Okay, so 6 repeated twice, so we don't need the 6, and 4 repeated twice, so we don't need this 4. Now we just need to multiply all these numbers. So 5 times 4 times 6 times 854. Using your calculator, you should get about a 102480. That should be your answer. So 102,480. That should be your answer. Okay, basically just that simple. Number 15. Let a triangle ABC be equilateral with perimeter 24. Determine the exact largest area of a rectangle with lower base on the x-axis and the upper vertices on the triangle. Okay, so let me draw this out. Then we have this triangle. Let's extend this out. And then box here. So we know we know ABC, this triangle, is a equilateral with a perimeter 24. So that means each of the three side lengths have equal lengths. So 24 divided by 3 is 8. So this side length is 8, this side length is 8, and this side length is 8. So if this side length is 8, you just basically need to know the 30, 60, 90 triangle, which is basically if we have a right triangle, right? And this is 30 degrees and this is 60 degrees. If this is hypotenuse is side length x, if this hypotenuse had the length x, then the opposite of the 30 degrees is x over 2. The opposite of the 60 degrees is x square root 3 over 2. So x times square root 3 over 2. Okay? So this is an equilateral triangle, right? So that means all the angles are 60. So this is 60, this is 60, and this is 60. So all that we really care about is basically this angle. So let's work with the side. So if this angle is 60, right? The opposite of 60 is x square root 3 over 2. So the angle is, this side length is 8. So 8 times square root 3. Oops, sorry, that's kind of ugly. 8 times square root 3 over 2 is equal to 4 square root 3. Okay. So the reason I did that is basically let's erase all the 8s because we don't need it. That means this height, right? This height over here, this is equal to 4 square root 3. Okay. And basically, since this is, as I said before, this is the 60, and since this is also 60, right? But it's cut by that length, right? By that line, that means it's cut in two. So that's a 30, and this is a 30. So since this is a 30 and this is an 8, right? Half opposite of the 30 is half of this length. So 8 of here, that means this is 4. Okay. So that means, let's delete this. That means this height is 4 square root 3 and this length is 4. Okay. So that means this slope is equal to negative 4 square root 3 divided by 4, which is equal to negative square root 3. So our slope for this equation is negative square root 3. Okay, so we have to put this in the equation is y is equal to negative square root 3 times x, which is our negative square root 3 is our slope, right? And then our y-intercept is from here to here, which is basically just our length of our height, right? So it's just plus 4 square root 3. So if you had to graph this line, right, the equation is y is equal to negative square root 3x plus 4 square root 3. Okay, so I'm going to delete this picture because it's kind of a little messy, and I'll redraw it. Okay, so we're trying to find this box over here. So if we have a coordinate right here, hypothetically, right? We think about it. If this coordinate has to follow this line, right? So it has to follow this equation. So basically, if we have an x coordinate right here, if we have x, this is our x, so it's 0 to x, so this is length x. If this is x, then this coordinate, this height is y, which is equal to square root 3 times x plus 4 squared 3. Okay, so this is our y. So the area of a rectangle, since this x is only from here, we need the entire thing, right? So this is also x, right? Because it's basically just mirrors of each other. So if this is a x, this is x, this is a y, right? So the entire area is just this x plus this x, which is 2x, times the y. So that's the area of a rectangle, which is equal to 2x. Substitute that y in, so you get a 2x times a negative square root 3x plus 4 square root 3. Okay, so if you simplify this out as a quadratic, you could get a 2x times negative square root 3x is equal to negative 2 square root 3 times x squared. And then 2x times 4 square root 3 is plus 8 square root 3x. Okay, and that will be, oops, let's move that up. And that will be equal to our area. Okay, right? Because this is our area, so that's we're staying the same. We just substituted something in. Okay, so then to find the maximum area, right? We want to find the exact largest area of that rectangle, right? The largest area means that we need to find the largest point in the largest y value in this equation. So all we had to do is basically find the maximum of this point, right? So as you know from quadratics, if you learned in class, which is basically negative b over 2a. So our b is 8 square root 3, so negative 8 square root 3, divided by 2 times a. A is our beginning coefficient, which is negative 2 square root 3, so negative 2 square root 3. So this 2 square root 3 cancel each other. So negative 8 divided by negative 4 is equal to 2, right? So this is our x value. So the maximum of y value is when x is equal to 2, right? So we know that's true. So that basically means we need to plug in 2 into our x, right? Plug in 2 here and plug in 2 here. So negative 2 square root 3 times 2 plus 8 square root 3, 2 squared, I mean, and then 8 square root 3 times 2, right? So that's 4, and that's negative 8 square root 3, and that is 16 square root 3. So our maximum area is 8 square root 3. And that is our answer, 8 square root 3 for number 15. Okay. Number 16. I is equal to square root of negative 1, and the line above a z denotes the complex conjugate of complex number z. Let a is equal to 2 plus 5i, and b is equal to 3 minus 6i. Determine the value of the conjugate of a plus b, and then the conjugate of that is equal to k plus wi. So determine the sum of k plus w. So the conjugate of a is 2 minus 5i, right? You always negative where the imaginary is, which is the I. And then you have that is equal to adding to b, so plus 3 minus 6i. So that is 5 minus 11i. And then you have to take the conjugate of this. So the conjugate of 5 minus 11i is 5 plus 11i, right? You just take the negative of the imaginary part. And that is equal to k plus wi. So k is equal to 5 and w is equal to 11. You add them together, right? So determine the sum k plus w. So 5 plus 11 is 16. So our answer for number 16 is 16. So number 17. Working at a constant rate, Jake could build a pizza in 3 minutes. So Jake's rate is 1/3, right? So 1 pizza per minute. So 1 pizza per minute. 1 pizza per 3 minutes, right? So that's his rate of working. And working at a constant rate, Elwood, I hope I pronounced that name right, can build the same pizza in 5 minutes. So he built one pizza in 5 minutes. Okay. So if there's no loss in efficiency working together, determine the number of minutes it would take for the two to build the same pizza together. So if they were working together, how long would it take them to make one pizza? So the rate of J is 1/3, plus the rate of Elwood is 1/5. So if we add their rates together and then we find out what time they work, so multiply by their time, equals to how much pizza they made. So they made one pizza, right? So 1/3 plus 1/5, that's if you add them together, this is the same thing as 5/15. This is 3/15, so that's 8/15, right? Times t is equal to 1. So 8 plus 5 is, 5 plus 3 is 8. 8/15 times your time is equal to 1. So your time is equal to 15/8 minutes, right? So your answer is just 15/8. If you want to write minutes, you could, but you usually don't have to write the units. So this is just a rates question, kind of simple. Okay, number 18. The following four order pairs 8, 18, -6, 12, 6, 12, 14, 16, 4, -4, 10, -8 represent points that lie on the same sphere. Determine the order pair XYZ such that represent the center of the sphere. Okay, so basically they've given us 4 points, and those 4 points, if you connect them all together, right, and you can make a sphere around it, basically. So basically how it looks is like we have 4 points. So, oops. I'm just trying to draw our axes. So this is the x-axis, this is the y-axis, and this is the z-axis, right? So we have something here, go to the back. So that's 8, 18, -6. 12, 6, 12, so somewhere around here. We have a 14, 16, 4, so somewhere around here-ish. And then we have a -4, 10, and -8, right? So since the points are right here, I'm assuming the center is somewhere around here. Actually, let's put it somewhere around here so you don't think it's on the axes, right? And basically what it is that if you draw a line from the center to each of these points, right? They should have the same length. So they're all the radius, right? Because that's a sphere, right? You connect all these points together, right? That point is connected to here. Kind of looks like a ball, right? You connect them all together, right? So basically, this point right here is the sphere, so it's right inside the circle, and then you connect all these points with kind of like curved lines. Basically, you make a sphere. So so the question is asking if we're given that these 4 points, right? How do we find that sphere? What is that sphere's center? So what's the coordinates of that center? So I'm gonna show you how to do it. I'm not gonna show why the this kind of method makes sense. But what we're going to do is that you're going to choose 2 points. So the 2 points I'm going to choose is 8, 18, -6, 12, 6, and 12. This is kind of a long process, so brace yourself. So it doesn't matter which 2 points you're going to choose. You just got to choose 2 points. And you got to do this 3 times. So make sure you choose three different combinations of points. So what you're gonna do is you're gonna have each of the coordinates subtract each other. So you're gonna have 8 minus 12, that's 4, and then you're gonna multiply that by 2. So 8 minus 4, 8 minus 12 is 4, is -4, times 2 is -4, is -8, right? And then you gotta put a in front of it. Plus 18 minus 6, that's 12. 12 times 2 is 24, right? You're gonna multiply whatever you keep subtracting, multiply by 2. And this time you're gonna put a b. And then -6 minus 12, that's -18, multiplied by 2, -36. Okay, and then put a c. Okay, so you don't need to understand why that works. Just make sure that you put it like that, right? Basically how I just read it. So you subtract each one from the respective coordinates, so the x minus x, the y minus y, the z minus z, and then each of that you multiply by 2. And then in front of the x one you put an a, in front of the y one you put a b, and in front of the z one you put a c. And then on this part, what you set it equal to, you take the square of each of the first one, the one that you work with, make sure you do it in this order, right? Don't take the square of this one first. Take the square of this coordinate first, the one that you're subtracting from. So you have 8 squared, and you add all those together. So 8 squared plus 18 squared plus negative 6 squared. Okay? And now you're going to take the square of the other coordinates. So it's going to be 12 squared plus 6 squared plus 12 squared. Okay? So when you have these two numbers, subtract them. So using your calculator, find out what that is. So 8 squared plus 18 squared plus negative 6 squared minus 12 squared minus 6 squared minus 12 squared. And you should get something of 100. Okay? So that should be your first coordinate. I mean, your first equation. And this is why we need 3, because we have variables a, b, and c. So we need 3 equations so we can find out what the variables are, what those variables equal to. So using those 2 points, delete, and we just need to save this. So this is our first equation. And now we're gonna have to repeat that process 2 more times. So let's say our next coordinates are these two. Okay, so we're just randomly choosing coordinates. So what I'm gonna do is I chose these 2 coordinates already, and then now I'm gonna choose these 2, and then I'm gonna choose these 2, because I'm just gonna go in order and include every single point. Right? You could just randomly choose any. It doesn't matter which one you choose in which order. Just make sure you follow the process correctly. So now you have 12, 6, 12. And you're going to have a 14, 16, 4. Okay, so 12 minus 14 is 2, negative 2. Negative 2 times 2 is 4, negative 4a. Okay, 6 minus 16 is 10. 10 times 2 is negative 10 times 2 is negative 20, so negative 20b. 12 minus 4 is 8. 8 times 2 is 16, so that's 16c. It's equal to 12 squared plus 6 squared plus 12 squared. Okay, so that's 14 squared, that's 16 squared, and that's 4 squared. And now you subtract both of them. Okay, so 12 squared plus 6 squared plus 12 squared minus 14 squared minus 16 squared minus 4 squared. And you should get a negative 144. Okay, so this should be your other coordinate. I mean your other equation. Okay, delete and delete. Okay, now let's do our final coordinates, which is 14, 16, 4, and negative 4, 10, negative 8. Okay, so 14 minus negative 4, that's 18. 18 times 2 is 36, so 36a. 16 minus 10 is 6. 6 times 2 is 12, so 12b. And then 4 minus negative 8, that's 12. 12 times 2 is 24, so 24c. Is equal to 14 squared plus 16 squared plus 4 squared, and then negative 4 squared plus 10 squared plus negative 8 squared, and then subtract those two, right? So you have 14 squared plus 16 squared plus 4 squared minus negative 4 squared minus 10 squared and minus negative 8 squared. And you should get 288. Okay, so deleting these because we don't need it. We don't need it. Now we have 3 equations. If you want to solve it by hand, the system equations by hand, you could. But what I'm going to do to save time, and since we're allowed to use the calculator, I'm going to use a matrix. So how this kind of works is we're going to make a 3 by 3 matrix. We have a negative 8, a 24, right? And then a negative 36. We have a negative 4, a negative 20, and a 16. We have a 36, we have a 12, and we have a 24. So this matrix multiplied by A, B, C, this is just a general idea of the matrix of how it works using system equations, is equal to our 100, negative 144, and 288. Okay, so what you're going to do is that you're going to multiply the right and left side of the equation by the inverse of this matrix. So negative 24, negative 8, negative 24, negative 36, negative 4, negative 20, 16, 36, 12, 24. and then you gotta raise it to the power of -1, which is basically just the inverse. So the inverse multiplied by this side would just cancel out the inverse and the if you multiply the inverse of a matrix by that matrix, you're gonna get the you're gonna get 1. Okay, sorry about that. So this side would just be A, B, and C. And then you're going to have this matrix multiplied by this, the 100, -44, and 288. So you're going to do this on your calculator. So you're going to make a matrix, a 3 by 3. So create matrix. So I use a TI Inspire. So it's pretty quick, and I think it's probably one of the best aside from the TI-84 for competitions. So -8, 24, -36, -4, -20, and 16, and then 36, and 12, and 24. Okay, and then you're gonna raise that matrix to the power of -1. So that gives us the inverse. Okay, and then you're gonna make another matrix, and that's a 3 by 1. So it's gonna be the other matrix is 100, -144, and 288, right? So it's this matrix. And now we're gonna multiply them together. So multiply the inverse matrix by the 100, -44, 288 matrix, right? And you should get a matrix in your calculator that outputs 7, 5, -1. And those are the coordinates of your x, y, and of your a, b, and c, which is in this answer, the 18 number 18 is x, y, and z. So your coordinates are 7, 5, -1, and that's your answer. So the answer for number 18 is 7, 7, comma 5, comma -1. Make sure you put it in this order. If not, then you get it wrong. And that is the way to do it. Overly long, but but it's pretty cool question to do. So if you don't solve this, it's understandable. It's long and kind of complicated. So undoubtedly 18 is probably the hardest in this contest. Okay, number 19. When polynomial px is divided by x over 20, the quotient is qx and the remainder is 10. So we have p of x, if it's divided by x over 20, our quotient is equal to qx, right? And we have a remainder. So we have a remainder of 10 over when we divide by x over 20. Okay. So what I'm going to do is that I'm going to multiply both sides by x over 20, right? So that will get us a p of x is equal to q of x times x minus 20 plus, and then x over 20 plus times x 10 over x minus 20 is just 10, right? So rewriting that equation, it's basically just this. Okay, so we know that is true, right? And then when q of x is divided by x over 17, the remainder is 24, which also basically means if you put q and you put 17 inside it, right? You find x is equal to 17, you put it inside. That means the remainder is 24. Okay, so determine the remainder of p of x when it's divided by x over 17. So the remainder of p of x when it's divided by x over 17, x minus 17, is just p of 17. That's how you get the remainder. So then p of 17, just plug it into this equation. So q of 17 is 24. 17 minus 20 is -3, and then plus a 10. Okay, so that's -72 plus that 10. So p of 17 is equal to -62. And that's your answer for number 19. It's basically just a bunch of rewriting equations. Okay. Number 20. The ellipse 25x squared plus 16y squared minus 128y plus 250x plus 479 is equal to -2 has vertices on the major axes on the form KW. Determine the coordinates of the vertex, which is basically a vertices, but singular, not plural, with w is equal to y. So the y coordinate has to be positive. Express your answer as an ordered pair x comma y. Okay. So first, let's make this into a ellipse, the general formula of an ellipse. So what we're going to do is, okay, so we're going to have a 25. So we're going to put the x's together. So 25x squared. Oops, that kind of doesn't look good too. Plus 250x. And then we're going to put the y's together. So plus 16y minus 128y. And then we're going to move the constant to the other side. So let me actually just move this equation over so I can fit it all into one line. So negative 2 minus 479 is equal to negative 481. Okay. So on this side, we have a 25, right? So our 25, we divide 25 from both the x terms. So we have 25x squared plus 10x. And then we're going to divide 16 from both of these y's. So 16, that's y squared. 128 divided by 16. What is that? 128 divided by 16 is 8. So that's minus 8y is equal to negative 481. Okay, so now we had to kind of complete the square inside, so 25. So we have x plus 5, and then that's squared. So x squared, and then x times 5 is 5x. Since this is squared, we need to multiply by 2, so that's going to give us our 10x right here. But we have the extra term, because this simple expands out to x squared plus 10x plus 25, right? So we have the x5 over here, x squared, and then the x squared over here, 10x over here, but we have an extra 25, okay? So that basically means we have that extra 25 plus this times this 25 means there's an extra 625 on this side. So we need add an extra 625 here. And now let's work on this one. So 16. Completing the square for this one. So y minus 4. So usually just half of the 8, right? So half of the 10 is 5, half of the 4 is, half of the 8 is 4, then square. So this is expands out to y squared minus 8y plus 16. So that gives us the y squared here, the negative 8y. We have an extra 16. Okay. So that means we have an extra 16 here. So 16 times 16 is 190, is 256. So we have an extra 256 on this side. So we need to add a 256 on this side. So that basically means our right side is equal to 625 plus 256 minus 481, which is 400, right? So all that simplifies to just 25x plus 5 squared plus 16y minus 4 squared is equal to 400. So to put this into convex form, you basically had to make sure this side is equal to 1. So you just need to divide this side by 400. So divide both sides by 400. So 25 divided by 25 divided by 400 is that's 16. So this side will be equal to x plus 5 squared over 16. And then plus, right? We're going to split this into two terms. And then 16 divided by that 400 is 25. So y minus 4 squared over 25 is equal to 1. So all we've been doing so far is that we're rewriting the equation. So then it's in convex form. So this is our convex form. So so whenever the number is bigger on the bottom, so 25 is bigger than 16, that means this is where the major axis is. So that's where our vertices are, we're going to add. So basically what it's going to look like is that we're going to have something right here. So the x is plus 5 and minus 4. So our center is at negative 5 and 4, right? So it's got to be somewhere right here. And our x is 16, so we have something like this-ish. Or maybe it's something like this, which I don't know, right? So W has, our vertices are going to be from here and here, right? Because 25 is under the y, so that means our major axis is under the y, okay? So for the y. So if our vertice is at negative 5, 4, right? Negative 5, 4. Okay. That means we just need to find out what this distance is. This distance is just equal to the square root of whatever that major axis is, right? So we have 25, square root of that is 5. So then we have to just add it to the y. So that's negative 5, 4 plus 5 is 9, and that is our coordinate. So the vertex where w is greater than 0 is, our w is equal to 9. So our k is equal to 5, and our w is equal to 9. I mean, our x is equal to negative 5 and our y is equal to 9. So this is our answer for number 20. And that's basically it. Okay, so as review, let's go back to number 1. Basically just know your polynomials, your logs, and know absolute values, exponents, radicals, and basically circles. Actually, just know all your connexes, which is your hyperbolas, your circles, your ellipses, and your hyperbolas, your ellipses, your circles, and your parabolas. Okay, and basically know your terms, like know what a domain is, know what a conjugate is, complex conjugate, and basically know what ellipses and like major axes, vertices is, right? And that's basically it. As review, I mean, as which questions are kind of hard. 18 is kind of difficult, as I shown. 19 is somewhat difficult. So sorry about that. 20 is kind of weird if you don't know what to do with conics or you don't know what a conix is. So conix, right? If you want to search that up, CONIC, right? And if you don't know what if you don't know what complex numbers are, uh, but basically that's it. Usually algebra 2 is just a combination of geometry and algebra 1. And that basically covers everything for algebra 2 2017 Regionals Division A ICTM. Thanks for watching, and I'll see you at the next math record.